Hello, in this video we're going to take a look at a couple of examples involving distance formula applications. Right, we have a Major League Baseball diamond is actually a square that is 90 feet on each side. What is the distance directly across the field from first base to third base? So let's actually put this on a coordinate axis system so we can get some points here. We'll let home base be at the origin, and then so that means first base is going to be 90 feet, and then second base is going to be 90 feet up from that, and then third base is going to be back 90 feet and up 90 feet from the origin. So if we want to find the distance from first base to third base, so first base is going to be at the point 90, 0, and third base is going to be at the point 0, 90. We need to find the distance between those 2 points. So our distance is going to be the square root of 90 minus 0, quantity squared, plus 0 minus 90, quantity squared. Remember, distance formula is just the difference in your x values squared plus the difference in your y values squared, and then take the square root of that. All right, so 90 squared is going to be 8100, and we can add those, but I also know that that's going to be 8100 times 2, and 8100 is a perfect square because that's how we got it, was 90. Square root of that's going to be 90, and then the square root of 2. And let's go ahead and find the decimal approximation of that. So if we plug in 90 times the square root of 2, we get 127.28 feet. Is going to be the distance between that, on that diagonal between first and third base. All right, we have two vehicles that leave an intersection at the same time. One is heading east at 50 miles an hour. So we've got one that's going this way at 50 miles per hour, and another one is heading south at 60 miles per hour. Find an expression that gives the distance in miles between the two vehicles after t hours. So what we're looking for is something that's going to look like this. This one's going this way at 50 miles per hour, so that means after t hours it's gone 50 times t miles, and the other vehicle heading south is gone 60 times t, and we want to find the distance in between. So we want to find this distance d in the middle. So our d is going to be equal to the expression 50t is the distance, that's going to be the difference between our x's, quantity squared, plus distance in our y's, we can call that original point 0, is going to be 60t squared. So simplifying that, 50 squared is 2500 t squared, and then 60t squared is going to be 3600 t squared. Let's see, I know we've got a common factor of t squared. We've also got a common factor of 100. So I'm going to go ahead and factor those out. That's going to leave us with 25 plus 36. 100 t squared is a perfect square. That's going to be 10 times t. Square root of 100 is 10. Square root of t squared is t. Underneath the square root, we'll still have that 25 plus 36. So that's going to be 61 underneath our square root. And I don't believe there's any perfect squares that go into 61. And so that would be our expression for the distance between those two vehicles after t hours.